The core difference, bulk versus match grade. Precision shooting is a game of millimeters, where the margin between victory and failure is thinner than a human hair. Fire standard military surplus at 100 yards, and a 4-inch spread is often deemed combat effective, a standard born from mass production necessity. For those demanding surgical accuracy, this inconsistency is an engineering disaster caused by the chaotic stacking of tolerances in every component. Precision match. Grade ammo eliminates this chaos by tightening every specification to an obsessive level. Switching to match, grade shrinks that 4-inch circle to a staggering 0.5-inch group, instantly increasing your accuracy potential by 800%. While bulk assembly lines churn out thousands of rounds per minute, match grade production moves with the deliberate pace of a master watchmaker. A single grain of sand weighs roughly 0.015 grain. Yet the propellant in these cartridges is measured to a consistency 3 times finer than that spec. This relentless pursuit of uniformity allows shooters to engage targets at 1,000 yards with total confidence in the physics of every shot. The brass case and internal uniformity. The brass case is the pressure vessel dictating the initial velocity of every shot. Standard manufacturing allows internal volume to vary wildly, but match-grade brass undergoes weight sorting to ensure every case is a mirror image of the last. A deviation of just 1% in case volume can shift your point of impact by several inches at long range, making case consistency the foundation of a repeatable shot. Engineers go as far as neck-turning the brass, shaving metal to a uniform thickness measured in 10,000ths of an inch. This precision ensures the tension holding the bullet is identical for every round in the magazine. When the powder ignites, the brass expands against chamber walls with predictable timing that prevents vertical stringing. By maintaining a 100% consistent internal combustion chamber, these cases eliminate the erratic pressure spikes that cause one bullet to fly high and the next to drop short. This invisible perfection separates a professional marksman from a casual hobbyist. Powder charge and thermal stability. The chemistry inside a match-grade cartridge is a masterclass in controlled energy release. Precision rounds utilize extreme powders designed to withstand the harshest environments. Whether hunting in frozen tundra at 0 degrees Fahrenheit or competing in a sweltering desert at 110 degrees Fahrenheit, your muzzle velocity remains virtually unchanged. This thermal stability is crucial because a change of just 50 feet per second can be the difference between a center mass hit and a complete miss at 800 yards. Physical measurement of the propellant is where the magic happens. Precision reloaders and high-end factories measure charges to within 0.02 grains, a level of scrutiny impossible on mass production lines. This obsession with weight ensures that the velocity standard deviation stays in the single digits, providing a flat and predictable trajectory. In the world of long-range ballistics, where gravity and air resistance are constant enemies, this level of propellant consistency is the greatest ally of a marksman. The primer, the flashpoint of precision. Everything starts with a spark. In a precision rifle, that spark must be identical every single time. The primer is the primary source of ignition delay, a microscopic lag that ruins long-range shots. While standard primers vary up to 10% in consistency, match-grade primers are manufactured to a strict 1% tolerance, ensuring a hotter and faster flash. This rapid ignition creates a uniform flame front, lighting the powder column with surgical timing. If ignition varies by even 0.5 milliseconds, the pressure curve shifts, causing the bullet to exit at the wrong point in the barrel's vibration cycle. This is why top-tier shooters seek a standard deviation in muzzle velocity of less than 10 feet per second. By eliminating inconsistencies in the spark, match primers reduce harmonic interference, ensuring the bullet begins its journey in the most stable environment possible. It is the smallest part of the cartridge, weighing only a few grains, but it carries the heavy responsibility of initiating the perfect shot. The BTHP design, mastering aerodynamic drag. When a bullet screams at Mach 2.5, the greatest enemy is the vacuum left behind. The boat tail hollow point BTHP addresses this by tapering the rear at a specific angle, typically between 7 and 9 degrees, mimicking a high-speed racing boat. This geometry allows air to wrap smoothly around the base, drastically reducing the low-pressure wake known as base drag. By minimizing turbulence, BTHP projectiles maintain a supersonic flight path for an extra 200 yards, ensuring the bullet doesn't tumble in the transonic zone. At distances like 1,000 yards, standard bullets struggle with the vacuum effect, pulling their heel, but the BTHP slices through, preserving kinetic energy. This profile allows for a significantly higher ballistic coefficient, often exceeding 500 G1 for match rounds, providing a flatter flight path resistant to wind. Born from fluid dynamics, this design ensures that once the bullet leaves the muzzle, physics works with the shooter rather than against them. It transforms a simple projectile into a master of aerodynamic efficiency. OTM and the secret of center of gravity. The tiny hole at the tip of an open-tip match OTM round isn't for expansion. Its purpose is far more sophisticated. In manufacturing, the lead core is inserted from the front into a seamless copper jacket, ensuring the base is perfectly flat and enclosed. Because the jacket is drawn from the base upward, imperfections are pushed to the tip, leaving the critical rear section with absolute concentricity. This allows the projectile to spin at rates exceeding 250,000 revolutions per minute without a hint of wobble. The open tip is a byproduct of this quest for balance. By concentrating the lid core toward the rear, engineers shift the center of gravity backward, increasing stability during high-speed rotation. This rear-biased weight distribution acts like a gyroscope, keeping the longitudinal axis aligned even through varying air densities over a half-mile journey. While hunting rounds are built to deform, the OTM is a mechanical masterpiece of equilibrium. The hollow cavity is simply the trash can for manufacturing tolerances, keeping the rest of the bullet pure and perfectly balanced. LDM technology and the heat shield revolution. At extreme velocities, the air in front of a bullet doesn't just push back, it burns. Traditional polymer tips, long favored for their sharp aerodynamic profiles, faced a hidden crisis discovered through Doppler radar. At speeds exceeding 800 feet per second, the intense friction heat actually melts the plastic mid-flight. This deformation causes the ballistic coefficient to degrade rapidly, resulting in erratic bullet drop at distances beyond 400 yards. The introduction of the heat shield tip marked a paradigm shift, using a high melting point propellant polymer that remained structurally rigid even as temperatures at the tip soar during the journey. By maintaining its perfect meplat or tip shape, the ELDM projectile ensures that its drag curve remains identical from the muzzle to the target. This thermal resistance allows for a BC that stays constant, rather than fluctuating as the bullet heats and cools. For the precision shooter, this means that a long-range solution calculated at the bench will hold true across the entire flight path, eliminating one of the most frustrating invisible variables in ballistics. It is a testament to how material science has evolved to conquer the physical limitations of high-speed friction. Monolithic solids. The peak of mechanical balance. While traditional match bullets rely on a lead core jacketed in copper, the extreme long-range community has moved toward a more absolute solution, the monolithic solid. These projectiles are not cast or swagged. They are individually turned on a high-precision CNC lathe from a single bar of solid copper or bronze alloy. By eliminating the union of two different metals, monolithic bullets erase the risk of internal air pockets or lead shift that can create a microscopic wobble at 150,000 RPM. This single material construction provides a level of mechanical concentricity that is theoretically impossible to achieve with a jacketed design. Because they are CNC machined, every dimension of a 200-grain solid copper bullet is controlled to a tolerance of 0.0001 inch. This extreme consistency is why they are the primary choice for shooters aiming at targets 2 miles away, where even the tiniest weight imbalance would be magnified into a miss by several feet. The sheer structural integrity of a solid metal projectile allows for longer, more aggressive aerodynamic profiles that would be too fragile for traditional manufacturing methods. It is the ultimate expression of quality over quantity, where each bullet is a bespoke piece of industrial art designed for one purpose: absolute stability. The Caliber Kings? Matching grain to goal. In the arena of precision, there is no one-size-fits-all. Instead, we have specialized tools for specific distances. For training and short-range bench rest, the .22 LR remains king. with match-grade variants utilizing specialized waxes and 40-grain lead bullets to achieve sub-MOA results at 100 yards. Moving to the mid-range, the 5mm Creedmoor revolutionized the industry by launching 140-grain projectiles with a ballistic coefficient so high it rivals heavy magnums, but with 30% less recoil. Selecting the right caliber is a delicate balance of managing wind drift versus shooter fatigue, ensuring you can maintain precision over a long match. When the mission profile extends beyond 500 yards, heavy hitters like the 338 Lapua Magnum take the stage, pushing massive 300-grain OTM bullets that carry enough kinetic energy to remain stable through the sound barrier. Each of these kings requires a specific bullet weight to harmonize with the barrel's twist rate. The true genius of match-grade ammunition lies in this tailoring, where powder burn rate and bullet weight are tuned to the specific physics of the cartridge. Whether it is a tiny rimfire or a thunderous magnum, the goal remains the same: repeatable perfection. Ballistic coefficient, the physics of air piercing. To understand how a bullet defies the atmosphere, we must look at its ballistic coefficient, or BC, a numerical rating of its ability to overcome air resistance. Think of the difference between throwing a paper airplane and a needle. The needle slices through while the paper plane is bullied by every gust. Match-grade ammunition is engineered with a high BC, often utilizing the G7 standard for long-range projectiles to provide a precise mathematical model of their flight behavior. A bullet with a BC of 650 will retain its velocity much longer than one with a 400 rating, staying supersonic for a greater distance. This efficiency is paramount when engaging targets beyond 1,000 yards, where even a 5-mile-per-hour crosswind can push a low BC bullet feed off course. Because match-grade rounds maintain momentum, they spend less time in the air, giving wind less opportunity to interfere. By maximizing the ratio of sectional density to aerodynamic drag, these projectiles achieve a flatter flight path and higher retained kinetic energy. For the shooter, a high BC is the physical insurance that the bullet will go where the reticle was placed, regardless of invisible air currents. Harmonic tuning, the perfect marriage of steel and lead. Even a perfect cartridge is useless if it doesn't vibrate in harmony with the rifle's barrel. When a shot is fired, the steel barrel oscillates like a tuning fork, a phenomenon known as barrel harmonics. If the bullet exits while the muzzle is at the peak of a vibration, the shot will fly wide. Professional marksmen use hand loading to fine-tune the powder charge in 0.1 grain increments, searching for the sweet spot where the bullet leaves at the exact millisecond the steel is momentarily still. This synchronization is why a load might shoot a 0.3-inch group in one rifle but a 1.5-inch group in another. By controlling barrel time, the duration spent traveling down the bore shooters ensure every projectile is released at the same point in the harmonic cycle. This level of custom tuning effectively negates the natural whip of the barrel, turning a mass of metal into a perfectly timed launch platform. It is the ultimate collaboration between reloader and machine, where powder chemistry and metallurgy are balanced to eliminate mechanical chaos. Match-grade ammunition relies on this surgical integration to find the specific frequency that allows your rifle to sing. Conclusion: the worth of a single shot. The high cost of match-grade ammunition isn't for the materials themselves, but for the removal of doubt. When you pay $2.50 for a single precision round instead of $0.50 for surplus, you are purchasing the elimination of every random variable. A match-grade shot is the culmination of centuries of ballistics evolution, from primer chemistry to the CNC machine tip. By narrowing tolerances to a microscopic level, this ammunition ensures that if the crosshairs were steady and the trigger brake was clean, the target will fall. This transition shifts the burden of performance entirely from the equipment back to the human. In a world where a 1,000-yard shot is influenced by the rotation of the earth and humidity, having a cartridge that behaves identically every time is the only way to achieve mastery. Match-grade ammo is the silent partner of the marksman, a mechanical guarantee that the laws of physics will remain constant from one trigger pull to the next. Ultimately, it turns the art of shooting into a repeatable science, proving that true excellence is measured in fractions of an inch,